All right, deep divers, ready to go deep on something that could totally rewrite how we think about pretty much everything.
Sounds intense.
It is. It's P versus NP.
Ooh, yeah, that's a big one.
Yeah, and today we're going to be unpacking this whole concept based on a YouTube video from Tem Scientia.
Okay, cool.
It's called P versus NP, the math problem that could change the world.
I mean, that title's not wrong. This isn't just like a fun little puzzle for, math nerds. This is a question about what we can even do with computers, like at the most basic level.
Well, let's just lay it all out there. What is the P versus NP problem?
So, at its core, it's asking, can every problem that's easy to check, if the answer's right, also be easy to solve?
Okay, so, if I can check if a Sudoku puzzle is solved, does that mean finding the solution was just as easy? Because it sure doesn't feel that way.
You got it. That's like the intuition behind this whole thing.
Okay.
And to be a little more technical, easy here means solvable in polynomial time. Those are the P problems. So stuff where the time to solve it only grows kind of reasonably as the problem gets bigger.
All right, so checking my Sudoku, even a giant one, that's a P problem. But what about actually finding the solution? Where does that fit in?
So that's where NP comes in. NP problems are the ones where you can check the solution in polynomial time, but you don't necessarily know how to get to that solution quickly.
Right. The video uses the traveling salesperson problem as an example.
Yeah, classic example.
Yeah, finding the absolute shortest route through a bunch of cities gets insanely hard the more cities you add.
Totally.
But if I hand you a route, it's not that hard to check if it's under a certain distance. So that's NP.
You got it. And that is where this core question of P versus NP pops up. Is every NP problem deep down also a P problem? Can we find some super clever algorithm to solve these hard problems just as easily as we can check their answers?
And what if someone does figure that out? What if P does equal NP? What changes?
Oh man, the consequences would be huge. I mean, we're talking about a fundamental shift in how we approach problems in every field. Imagine protein folding, the thing that's key to understanding diseases, developing drugs.
Yeah.
What if that became as easy as solving a simple equation?
So no more years of lab work just to figure out what one protein looks like.
Potentially, yeah. And think about logistics, optimizing delivery routes, managing global supply chains. All these super hard problems could become solvable like that.
Okay, so we're talking massive benefits to science, to industries. But the video also mentions some pretty scary downsides, right?
Yeah, the big one is cybersecurity. Right now, a lot of our encryption relies on how hard it is to factor really big numbers.
Okay.
And that's a problem that we think is in NP, but not in P. If P equals NP, boom, suddenly our encryption systems could just, evaporate.
So online banking, all our secure communications, just gone. That's a little unsettling to think about.
It is, yeah. The stakes are, ridiculously high.
Yeah.
But even beyond that, P equals NP has some pretty deep philosophical implications.
Oh. I'm intrigued. Tell me more.
Well, think about it. If any problem that's easy to check is also easy to solve, what does that even mean for human creativity, ingenuity? Do those things even have the same value anymore?
Yeah, we value those things partly because they seem so rare, so hard to do. But if a computer could just whip up a symphony or write a novel, would those achievements still feel as impressive?
Exactly. It makes you question, what does it even mean to be intelligent, creative, even human in a world where complex problems become easy to solve?
That's a fascinating and honestly kind of terrifying thought. It's P versus NP isn't just about algorithms. It's about the limits of what we can know and what it even means to solve a problem in the first place.
It is. It really is.
Yeah.
Makes you wonder if we've been thinking about solving things all wrong, doesn't it?
Totally. And to really get into this mystery, we have to talk about this thing called NP complete problems. Okay, I gotta be honest, that sounds kind of scary. Way too mathy for me.
Yeah, it's not as bad as it sounds. Think of these NP complete problems as the toughest guys in the NP club. They're the gatekeepers.
Gatekeepers, what do you mean?
So if you find a fast way to solve any one of these NP complete problems, you basically crack the code to solve all NP problems quickly.
Whoa, seriously, cracking one NP complete problem is finding the master key to the whole NP world.
Exactly. It's like this secret passage that leads you to the solution of any NP problem you can imagine. That's why they're so huge in this whole P versus NP thing.
Okay, I'm getting why these NP complete things are such a big deal, but how do we even know which problems are NP complete? It's not like they come with a little label, right?
Well, no, but there are ways to figure it out. It's a little technical, but basically You can prove one problem is NP-complete by showing that it's at least as hard as another NP-complete problem that we already know about. It's like a chain of connections.
So is there like a list somewhere, like a top 10 most wanted list of NP-complete problems?
There are actually quite a few well-known ones that researchers have been banging their heads against for decades. The video mentions one that you might not expect: Super Mario Bros.
Wait, the video game. Super Mario Bros. Is an NP-complete problem. I feel like I missed something there.
It sounds weird, I know, but it shows something important. Imagine someone designs a Super Mario level that represents any given NP problem. If Mario can beat that level, it basically proves that the problem has a solution.
So beating the level is like finding the solution to the corresponding NP problem. I love the idea of mathematicians duking it out on Super Mario to solve these mysteries.
Aha, it's a good way to think about it. It shows how powerful these NP-complete problems are for understanding the big picture of computation. Like, if you can crack Super Mario, maybe you can crack NP.
That's a big if, though, right? I mean, most experts seem to think that P doesn't actually equal NP.
Yeah, true. There's no proof either way, but the consensus leans towards P and NP being different.
So why even bother with all this if the odds are against us? Why put all this effort into something that might not even have an answer?
It's a good question, and it gets to, like, the core of why this problem is so fascinating. Even if P and NP are different, trying to understand why they are is where a lot of the interesting stuff comes up.
Okay, gotta elaborate on that. What's so interesting about knowing why they're different?
Think about it. This whole quest to solve P versus NP, it's pushed the boundaries of computer science in some really huge ways. Like, we've got new algorithms, a way deeper understanding of how complex things are, even connections to stuff like physics that you wouldn't expect.
So it's like we're exploring this uncharted territory, and even if we don't find the treasure, we're still making these amazing discoveries along the way.
Exactly. It's about the journey, not just the destination. And you know what's interesting? The video mentions that when companies realize they're dealing with an NP-complete problem, it often changes their whole strategy.
Oh, really? How so?
They basically give up on finding the perfect solution. It's like NP-complete has become this code word for too hard, let's find a workaround.
So instead of searching for the optimal solution, which could take, like, forever, they just focus on something that's good enough.
Yep, they go for practicality over perfection, which makes sense for a business.
That is super interesting. It shows just how deeply this, like, theoretical math problem has influenced the way people actually make decisions in the real world.
Absolutely. It shows how this idea, as abstract as it is, has trickled down into how we approach problem solving in our everyday lives.
Crazy. Okay, so we've covered a lot of ground here. We talked about, like, the theoretical stuff, the whole cybersecurity thing, even the philosophical questions that come up with this whole P versus NP thing.
Yeah, it's a lot to unpack.
It is, but, like, let's bring it back down to earth for a second. What does all this mean for, someone like me, someone who's not, like, a math whiz or a coding guru? Why should I care about P versus NP?
That's actually a really important question, and it kind of gets at why this problem is so fascinating to so many people. You don't have to be, like, a super technical expert to get something out of thinking about P versus NP. It's about these really fundamental questions, like, what are the limits of what we can know? How complex can things get? What's even possible? It's a problem that makes you rethink how you see the world.
So you're saying it's almost like philosophical.
Totally. It makes you question what we can do, what computers can do, how much we can ever really understand. Imagine a world where all this stuff that seems impossible now, like curing diseases with a few lines of code or like having perfect solutions to all these crazy problems. Imagine if that was just like everyday life. That's the potential upside. But then there's the other side. What if it breaks everything? What if all our security, all our privacy is just gone?
It's like opening Pandora's box. We might find amazing things, but also unleash a whole bunch of new problems.
Yeah.
So are we any closer to knowing what's actually in that box?
That is the million-dollar question, literally. Nobody knows for sure if P equals NP. It's still one of the biggest unsolved mysteries in math. But even without a definite answer, just trying to figure this out has changed how we think about computation, about how we solve problems in some really profound ways.
It's like this grand adventure, you don't know where you'll end up, but you're making incredible discoveries along the way.
That's a perfect way to put it. And who knows, maybe one of our listeners will be the one to crack the code. Maybe you'll be the one to solve P versus NP.
Well, that's a pretty inspiring thought to end on. We've gone deep, deep divers into the world of P versus NP. We've talked about how it could revolutionize everything from medicine to cybersecurity, and even how it makes us question what it means to be human in a world where computers can potentially do anything.
Yeah, we explored P, NP, those tricky NP-complete problems, those gatekeepers of complexity. We even touched on quantum computing, which could change this whole game in ways we can't even imagine yet.
As we wrap up this deep dive, we want to leave you with one last thing to think about. If we could solve any problem as easily as we can check if the answer's right, what would that mean for humanity? Would it be this amazing leap forward, or would it create a world where, like, human ingenuity doesn't even mean the same thing anymore? It's a tough question, but it's one worth asking.
It really is. Thanks for joining us on this journey, Deep Divers. We hope you keep exploring these ideas, keep diving into the mysteries of computation and problem solving, and make sure to tune in next time for another deep dive into a whole new fascinating topic.